Hi, this is Xinrui Fang, the master student from Q University Life Still Computing Lab. My collaborators are Chen Shuoxia and Yota Skula. In this work, we propose facial pen, using facial detection to augment pen-based interaction. Nowadays, pen-based interaction is a popular interactive technology and has been widely researched. A lot of researchers focus on improving the usability of the pen-based interaction. However, some of the work faces issues of occupying non-dominant hand and extracting dominant hand from work to gesture input. Both kinds of work above interrupt the continuity of creation. In order to improve this issue, we propose facial pen. The facial camera is mounted at the rear end of stylus. It can free both hands from gesture input and focus on work. In this work, we exemplify the pen-based interaction system driven by facial expressions, and we define user-proposed facial gestures with an elitization study. Here's the overview of our system. As image A shows, user can hold stylus randomly. B is an example of usage scenario, and C is camera view captured by the facial pen. In order to find the gesture command relationship, we implemented an elitization study. 8 participants were recruited in this study. Finally, we selected the highest 7 elicited gestures in our system. Here's the one initial stance and the other 7 elicited gestures. Facial pen stylus prototype is combined with 3 parts: the USB facial lens camera, the 3D printing combination part, and the Wacom stylus. Here's the detection pipeline of the facial pen. The raw image captured by the camera is 640 multiply 480 pixels. Then, PCN is used to detect face region, crop and resize to 64 pixels. Then, the processed image is fed into the VGG19 neural network for further classification. In order to improve the detection accuracy, we designed a calibration system. Here's user interface of our system. Region A is used for users to calibrate their positions. B is a button for users to click and capture image data. And C is a reference image to remind users. Here's the results comparing before the calibration and after the calibration. A is the classification result of best module from 13-fold cross-validation without calibration. The average accuracy is 85%. B is the classification result of fine-tuned module after calibration. Average accuracy is 94%. A and B validated on the same validation site. We then designed the drawing application to prove the feasibility of the facial pen. In order to reduce false positive, we added time duration for each gestures. Different time period is given to different gestures, according to the dangerous extent and the false triggered possibility of the gestures. This is a recorded video of the drawing application.
User can open mouse to plus line weights. Shrink check to minus line weights, separately or continuously. Green to switch between eraser and pencil. Close eyes to clear canvas. Say left to undo and say right to redo. Lift eyebrows to open or close the palette.
In order to prove the usability of the facial pen, finally, we implemented the user study. 10 participants were recruited in this study. They were required to copy and printed simple cartoon unicorn character with a facial pen. We summarized some interesting findings from this study. The details can be referred to in our paper. Thanks for listening.